Ladies and gentlemen, I'm delighted to welcome you to today's webinar, The Benefits of Innovative Grid Technologies Make Europe Fit for 55. I'm Susanne Nies, the chair of Current Association of Innovative Grid Technology Companies in Brussels. And today's event is going to launch the Consentec study that our now 1.5-year-old association has commissioned to the well-known consulting company Consentec that is based in Aachen. And I don't think I exaggerate if I say that today we have two important events. One is the launch of the new German government in my hometown, Berlin. And the second is the launch of this Consentec study. And I'm delighted to see outstanding speakers that joined us today, starting with the moderator, Siobhan Hall. Siobhan has been working long time for Platz, is a very familiar face to everyone that is part of the energy agenda in Brussels and internationally. Now she's working for Montel. She's going to be our moderator today. I'm also very delighted to see Christoph Maurer, who founded Consentec, who is its CEO, and the consultant Tadeusz Kreisig, responsible with Christoph for the study. We have Giles Dixon from Wind Europe, and you see the background of Giles Dixon doesn't have the windmills that we have to build till 2030, and he will explain what needs to happen to have those. We have Gert Brunekrift, who is from the Jacobs University in Bremen, who is an outstanding regulatory expert about regulation that brings networks up to speed. Jan Kostevs from ACER that recently published a report that looks at efficiency of networks. And Antonella Battaglini, who founded the Renewable Grid Initiative that brings together NGOs on the one hand, TSOs on the other hand, in order to deploy grids faster. Alan Gross is a familiar phase 2 working for TenneT, but now also leading a working group in NSOE. And we are very happy to have you, Alan, with us today to discuss this report. Finally, my, I would say, a colleague since long time, Anders Scanlund. We already worked together in NSOE times. Anders is now working for Heimdall Power and is going to conclude today's webinar. He's a board member of Current. So let me introduce and set the scene with some first slides. Next slide, please, then. So this is where we are. On the left side, you see a promising windmill and still a lot of coal, a lot of carbon-heavy industry that we need to overcome. We definitely need to jump across this abyss to reach a future that is clean, that is green, and that takes us to net zero. Next slide, please. When you look at this slide here, you see on the right side the pledges that have been hard to agree upon by Glasgow. Minus 6.3 billion metric tons of CO2 have been negotiated successfully across all sectors. However, when you look on the left side, you see what's needed until 2030 to really reach the net zero, or to reach the net zero agenda. This means 26.8 billion metric tons across all sectors, which is 4.2 times more an effort from what Glasgow has just promised us, and Glasgow isn't even done. That means a lot more efforts are needed, and with our webinar today and the study by Consentec, we are not able to bring the answer, but we are able to bring a part of the answer to this story. Next slide, please. So let me say some words on why the grid is so essential. Could you click on the slide again? Please. Yes, so it's several elements of making the grid so essential. So the first part, of course, the net zero requires huge investments into the network. Only on Europe's scale, it is 30 billion to 60 billion per year by 2030. In my country, Germany, it is about 84 plus billion alone to 2030. We all know that the energy transition is about more renewables, about distributed generation, about a higher demand of electricity. I read, by the way, that TenneT, we have Alan Gross here, is now connecting a data center directly to the high voltage grid. Electrification, more electricity demand, storage, e-mobility, and the new market design paradigm. The grid is the bottleneck, the grid is the enabler in this story, simply because electricity doesn't flow without grids, and storage will always be limited. We need an integrated digital grid, a single holistic multi-directional system, which is the critical platform to unleash the energy transition. We mean net zero. Next slide, please. So that is Current. What is its vision? Current wants to see the European power network being the recognized world leader in enabling decarbonization through the efficient use of modern grid technology. Having worked formerly for ENSOE, I must say I was learning to be proud of this integrated electricity system, as it is especially represented by the regional group Continental Europe, a huge integrated zone. But let's take it now to the next level and let's make it this recognized world leader. Current encompasses a number of companies that include technologies like dynamic line rating that are able to increase, to maximize the use of the existing grid with sensors. That includes also companies like Supernode or Vision Electric that are there to optimize the way how lines are done today. Superconductors can take by manifold the capacity of electricity into the system. And then also a company like Smart Wires that I'm representing with my second casquette. We are doing the so-called modular SSSC, and we are a power electronics device that equally enhances the use of the existing grid. Other companies that we are representing, Depsys or Greenwood Power, are working with solutions for the distribution network. Next slide, please. So how can we modernize the grid? What needs to happen? It's clear that innovative grid technologies include a lot of things that are on the shelf. It's not about a far beyond future. Data analytics, modeling, topology optimization, all these things are there. And what we are doing is we address congestion, very expensive. Again, in Germany, we're talking about 1.8 billion euros year by year these days. Congestion includes curtailment of renewables, unlocking the queue, resilience, harmonics, optimization, and future proofing. Next slide, please. So it is all about the transition from a CapEx-based, copper and steel-based system to a grid that is more a combination of both, that includes also silicon and also software. And when you look at the costs of copper, only the costs of copper have been increasing by 14,000 euro very recently, reaching now 14,000 euro, and they increased by something like 1,000 euro in a month. We need to go for a more intelligent system that is what we call the future grid. Next slide. I also wanted to do justice to a report that Acer has just published on 22nd of November, and Jan, who is here, is going to talk about it. We see more and more reports. This report looks at how should we incentivize smart investments to improve the efficient use of electricity transmission assets. A very interesting read that Jan is going to explain. And my last slide, we just asked the question, why is it not happening? I leave you with that question. And I suppose that Anders, in the end, when he's wrapping up, we'll come back to that question. So many reports are out there, be it the one by Ecorist in 2019 to the Infrastructure Forum about the regulatory frameworks, Wind Europe, making the most of Europe's grid, the Ministry in Germany for Economics, from today, Ministry for Economics and Climate, about operational devices, incentivise Technopedia, or our sister association in the US, WAT, have been publishing on the matter. We want to see it happen. Why is it not happening? I hand over to Siobhan to introduce our speakers.
Thank you very much, Susanna.
Yeah.
Thank you very much, Susanna. And that was an excellent overview of where things are now. And you also introduced most of the speakers already. So I'm only left to introduce our two consultants who are going to be presenting the report that we're all very anxious to hear about. And they are Christoph Maurer, who's the Managing Director of Consentech, which is the consultancy that has produced the report, and Thaddeus Kreisig, who is his colleague. They are going to take about 20 minutes to present the report. And then we're going to have a panel debate with the speakers that Susanna introduced earlier. So we'll have a short introduction from each of those, and then we'll have a Q&A session. So for everyone who's listening, the slides are going to be circulated afterwards. You can ask questions in the Q&A box. And, it's a great opportunity to ask questions of all the speakers we have today. So please do ask questions. It makes it much more interesting. So with that, I'm just going to hand over to Christoph and Thaddeus, and you have the floor.
Thanks, Siobhan. And thanks for having us today and having the opportunity to present that very interesting study. I think Susanna has already mentioned the importance of grids and transmission systems to make that energy transition that we urgently need viable. And I'm totally convinced that transmission and cross-border exchange of electricity is, let's say, the most important and most efficient flexibility option we have in that system, and it's urgently needed. And I think we all agree that the grid expansion is necessary. Unfortunately, we see that our transmission grids are heavily loaded today, but transmission expansion is somehow fallen behind, which is not because of the transmission system operators not wanting to expand their grids and to reinforce their grids, but because of public resistance. On the other hand, we all know that we'll have to, let's say, build up renewable electricity capacity much faster than in the past if we want to meet our 2030 targets. And I just want to remind you of the new 80% target of the newly installed German administration. So 80% renewables share in the German electricity system until 2030. That's a real challenge, and transmission systems will be needed to meet that target. And that's why we wanted to investigate within that report that I'm going to present to you today, which contribution could be made by innovative technologies as represented by the current members here in order to help ensuring a cost-efficient integration of renewable electricity. And for that purpose, we investigated 3 different innovative technologies. I'll introduce those technologies on the next slide. We did a quantitative assessment, which was focused on, let's say, the impact on congestion management, but there are also a lot of, let's say, rather qualitatively evaluated benefits we'll find on that in the report. And I cannot mention all these issues today in the presentation with a limited time frame, but you'll find in the report some interesting remarks on the potential of these technologies. So, Christy, next slide, please. The 3 technologies we considered here are dynamic line rating, then the modular static synchronous series compensator. That's an awfully long word, so I'll simply use the abbreviation MSSSC, and superconducting cable system. These are technologies which are offered by the members of the current association. And I think it's worth to mention here that there's some different maturity of these technologies, with some of them more or less already available on the shelf, and others being options which should be more considered for the medium-term integration of renewable electricity. Just wanted to give you some thoughts on why these technologies are important. So dynamic line rating is perhaps the most famous one of these technologies, and obviously is already discussed a lot, which means that you, let's say, determine the actual rating of transmission lines in system operation, taking into account ambient conditions, weather conditions, like cooling effects of wind and temperature, which means that actually you can increase the line rating compared to traditionally used static line ratings. What is quite important here, and what was considered in our study, is the idea of having, let's say, a sensor-based dynamic line rating, which includes, let's say, the idea of making use of data and digitalization, as mentioned by Suzanne. And we think that with such sensor-based dynamic line rating, we can largely reduce security margins, which today have to be applied when using dynamic line rating. And that's why we considered the impact not of only applying dynamic line rating. In fact, we assumed that dynamic line rating was largely applied in our scenario we considered here, but we assumed the impact of having sensor-based dynamic line rating, which would allow to reduce security margins in the application of that technology. The next technology, the MSSSC, simply, let's say, deliver additional capabilities to traditional transmission systems, AC transmission systems, which we, let's say, have been urgently missing for a long time now. So you all might be aware that in typical IT networks, it's possible to route flows and communication, which is simply not possible in meshed AC transmission systems, because their flows follow Kirchhoff's laws. And you might well end up in a situation with today's AC transmission systems where one line is overloaded, while at the same time other lines still have spare capacity. And that's where MSSSCs now contribute by having the capability to reroute flows within an AC transmission system and do that on a modular and very simple to apply basis. And by that delivering the capability to relieve congestion as long as there's some spare capacity available. And we considered that in another scenario where we implemented, in our scenario here, 17 MSSSC elements. The last aspect or the last technology we considered here are superconducting DC systems, which, well, more or less might be a technology of the future here. The idea of superconducting cable systems is that they typically have more or less close to no resistance. Therefore, we could simply transmit much more capacity or much more electricity over a cable system than we can do with traditional HVDC cable systems, even at lower voltages than today. And superconducting DC cable systems might be a very economic option for long distance power transmission. We tried to simulate that effect by having, let's say, two sensitivity options we considered in the study. One is where we, let's say, simply modeled the effect of an additional HVDC cable system, which was not included in our reference scenario. But what might be even more interesting is the second scenario, where we assumed, based on the cost data that we were provided with by Karen, that a superconducting DC cable system could be built with, let's say, more than twofold the capacity of a traditional HVDC cable system at the same cost point than with today's technology. So we modeled an additional HVDC system in our reference scenario with a 2 times 4.5 gigawatt capacity compared to a 2 times 2 gigawatt capacity for today's HVDC systems. Now, these were the technologies considered, and we applied them separately, but also together in a combined scenario. And I'll now introduce you to the modeling and to the results of our study. Next slide, please, Christy. So just a short note on what we did. So our modeling was focused on the target year 2030. I think that makes sense given the targets we have. we mostly relied on the national trend scenario from the last TIWA NDP, but modified in order to approximate the Green Deal. Regarding the modeling, we covered the entire European system in our market simulation and applied, let's say, latest standards like flow-based market coupling. It might be worth to note that within that model, we assumed that gas-fired power plants are more profitable and preceding coal-fired power plants in the merit order. And we have the results show that we have much more cross-border trade compared to today. And what also might be interesting that other than today, Germany in that model for 2030 is a net importer, no longer a net exporter. We took then the market simulation results and put them into the grid and then pursued load flow and redispatch simulations. We did a power grid modeling for the entire continental European system, but especially we did then a fully integrated cross-border congestion management and remedial action simulation for the region, which is depicted in green here. So France, Germany, the Benelux countries, Austria, and Denmark West. It should also be noted that for that simulation, we assumed that all grid expansion projects which are currently underway and planned to be commissioned until 2030 are really commissioned until 2030. Now, that's a rather optimistic assumption. So we do not want to let's say, exaggerate the effect of the innovative technologies by well, assuming a very pessimistic scenario for grid loading here. So it's a rather optimistic assumption on the loading of the grid. We took out one of the planned HVDC connections in Germany in order to be able to perform that sensitivity analysis on superconducting cable systems. So next slide, please. What we then did, I already mentioned, we started with defining the scenarios. We then performed the market modeling with a flow-based market coupling. Out from that flow-based market coupling, we got the market-based infeed of all the generation assets in our model and having additionally the information on the sides of the different generation assets, we could break down the market outcome, let's say, to nodal load and power injections to the power grid. So we could transfer the market result to the grid. With that, we did a grid simulation, load flow and contingency simulation, finding the congestion in the grid, the congested area, the areas with high overload. And then, and that I think is the focus of the study, we first simulated for a reference case, so without those innovative technologies, what would be the efforts to relieve the grid and to maintain system security, so in terms of redispatching volumes and costs for congestion management. And on the other hand, we compared this outcome for that reference scenario with the application of the innovative technology. So we compared what would be the benefit of applying sensor-based dynamic line rating, of applying MSSFCs and superconducting cables, and also in an additional and last scenario, we combined all these innovative technologies to see where that could get us in terms of benefits for congestion management and renewable electricity integration. So next slide, please. And now I would like to first introduce you to the results of our reference scenario. So this is what congestion management in the reference scenario in the mentioned countries and bidding zones looks like. So we end up with a grid which is quite significantly congested. As mentioned, we have rather optimistic assumptions on grid expansion until 2030 within that study. So actually, the situation in 2030 could look much worse than depicted here, with even higher congestion management, and especially if we remember the 80% target now from the new German government, there might be additional congestion even with an optimistic assumption on grid expansion. What the diagram shows here is that we end up, especially in Germany, I think that's not really surprising to anyone who has dealt with congestion management studies in the past, especially in Germany, we have quite a significant amount of congestion, and especially, and that's the green bar here, we have quite a significant amount of rest containment, which is necessary to maintain system security in our reference scenario. 80% of that containment is onshore wind. located somewhere in Germany, which could not be integrated into the system due to congestion. And we end up with 550 million euros per annum of congestion management cost in that 2030 scenario. So that's our reference case now, and now I'd like to show you the benefits which can be achieved with the different innovative technologies we considered in the study. So again, the columns on the left here are the reference scenarios, so the data you have already seen. And now we first look at the columns, let's say 2, 3, and 4. So where we applied and deployed the innovative technologies separately from each other. And what we see is that each of them, or especially dynamic line rating and the MSSSC, can reduce the volume of redispatching and the congestion management costs by roughly 40 to 50%. And they can also integrate much more renewable electricity in the transmission system than without that innovative technologies, because they simply reduce congestion and therefore reduce the need for curtailing renewable electricity production. For the superconducting cables, we can also achieve significant reductions in redispatching costs. And I think it's worth to split the effect depicted here. So we have about, let's say, 60% reduction compared to the reference scenario, where one HVDC system, which is currently planned, is not realized. But we also have up to 30% reduction of congestion management costs and volumes compared to, let's say, the scenario where we would have an HVDC connection of 2 times 2 gigawatts included in the system, simply because of the effect that the superconducting technology might allow to, let's say, deliver additional capacity. So here 2 times 4.5 gigawatts at the same price tag than conventional HVDC capacity or HVDC systems with 2 times 2 gigawatts of capacity. Though each of the 3 technologies deliver significant benefits, and what was now interesting for us is to see whether they would or behave rather as substitutes to each other or somehow complementarily. And that's why we did or calculated an additional and last scenario where we applied all these 3 technologies. So just could you please stick to that slide? Thanks, Christy. So we applied a last scenario where we combined all these technologies, and we found it really astonishing that in that scenario, we could achieve a reduction in congestion management costs and volumes of roughly 90% here. So that mainly proves to us that these technologies behave rather complementarily than as substitutes to each other. Obviously, in a grid which might be more heavily loaded than the one we considered here, it's not sure that we would at each and every time receive a 90% reduction in congestion management volume. So that's not the main idea, but it will at any time be a significant reduction which can be achieved by these technologies. And what is rather more important is that they be or show to behave in a complementary manner. So next slide, please. I think I'm already running out of time here, but this is also my last slide, and I just wanted to, let's say, introduce you to what in my eyes or in our eyes are the main messages and the main conclusions from the study. And I think that's a rather optimistic outlook because what we find and could prove in the study is that there are innovative technologies available with dynamic line rating, MSSCs, and superconducting cable systems, which can each significantly reduce volume of congestion and congestion management costs. And that will facilitate, let's say, the necessary speed up in renewable electricity deployment and the integration of renewable electricity, which is urgently needed to meet our targets. And additionally, and also as a rather optimistic outlook, the complementarity of these technologies was not sure from the beginning of the study. So we were really curious what would be the effect here and whether they would show to behave in a complementary manner. And well, I think it's a good outcome of the study and really optimistic outcome of the study that this study showed the complementarity of the different considered innovative technologies. I would just like to mention, and the report gives some additional insights on that, but there's are other things which could be elaborated, which were not part of the study here. that it's not only the reduction in congestion management costs, which could be achieved from these innovative technologies, but they might also bring additional benefits to the system. For example, if you think about provision of non-frequency ancillary services, reactive power, and so on, which could be done, and increasing the let's say level of knowledge we have on the operation of our systems by having available more data and so on. Though these additional benefits at least should be considered when thinking about the deployment of these technologies. And one last remark, let me conclude with one last remark. These innovative technologies have shown to be, let's say, efficient options to meet our targets and to meet the demand we're facing, but they are not meant in our eyes as a substitute to grid expansion and grid reinforcement. We will need both, most likely. So the challenge is that huge. We will urgently need grid expansion and grid reinforcement, but most likely we will not make it only by grid expansion and grid reinforcement, but we will also need to deploy these or such innovative technologies in order to meet the 55 target in 2030 and let's say the longer term decarbonization targets we all have and we are all committed to. So thank you for your attention, and I'm looking forward to the panel discussion and later to your questions. Thank you.
Thank you very much, Christoph. So just to be clear, that's the end of the presentation. There's no more on the report to come from consent text side. Yes, we're going straight to the panel debate. Is that right?
Yes.
Yes. Okay. Brilliant. So thank you very much, Christoph, and that was a really interesting presentation there. And I really heard the main takeaway there, which is there is so much renewable energy that needs to be integrated in the coming years that it will need grid expansion, grid reinforcement, and a combination of innovative technologies to make it work. So I see that we are starting to have some questions come in. If you would like to ask a question, please put them in the Q&A box. I also saw people are raising their hands. We don't really have a raised hand issue.
Maybe Siobhan, since there's questions directly now to Christoph, it makes sense, sorry for saying the difference before, maybe useful to have some Q&As just now on the report.
Okay, but I just want to say for the people raising their hands, can you, if you have questions, can you put questions in the Q&A box? We're not going to people directly. So if you've got a question, put it in the Q&A box. And as Susanna said, we do have a couple of questions that I can put straight away to Christoph, if you're happy to take a couple of questions.
Yeah, of course. So Dionysos is asking if whether we could, let's say, estimate the cost-saving contribution of each technology in the combined scenario. Unfortunately, I don't think that's possible. It's simply the let's say the property of the combined scenario that will simulate the effect of all these technologies together, and not it's not possible to, let's say, allocate the cost-saving effect to one of these technologies, but they all contribute here to the cost reduction. And then there was a question by Miha Jenstel whether the displayed congestion management costs are on a net basis. I think the answer is a little bit mixed here because for the superconducting cable system, effectively it was designed in a way that 2 times 4.5 gigawatt cable system had the same cost level as a conventional 2 times 2 gigawatt cable system would have. Whereas for dynamic line rating and the MSSFC, it's not on a net basis, it's on a gross basis here. But we did a rough estimation, and let's say the costs for deployment of these technologies will be significantly lower than the benefits that they would bring, at least. So there definitely will be a positive cost-benefit analysis. Nevertheless, we had to take some, let's say, rough assumptions here. For example, we assumed dynamic line rating on each and every line. If you did a line-wise cost-benefit analysis, it might turn out that there might be lines where dynamic line rating will bring a very high benefit, and others where you could well, refrain from applying it there. But within that limited study and then the limited time frame we had for that study, that was not possible to investigate in detail.
Okay. Well, thank you very much, Christoph. That was some very comprehensive answers to those questions there. So we are now going to go to our speakers. And can I just ask people again, if you do have a question, can you put them in the Q&A box? So not the chat box. Don't raise your hand. Put the questions in the Q&A box. It makes it much easier for us to answer your questions. And now we're going to hear from Giles Dixon, who is the CEO of Wind Europe. And we heard earlier from Christoph how we will still need grid expansion and we will still need a lot more renewable energy technology going forward. So Giles, can you give us a comment on what you think of the report and how you see it affecting the uptake of wind? And you have 6 minutes. So Giles, the floor is yours.
Thank you very much indeed, Siobhan. Good afternoon, ladies and gentlemen. Thank you to you, Susanna, and your colleagues at Current for organising this webinar. Thank you for having commissioned the excellent Consentec report. And thank you to Christoph and all of your team at Consentec for having written the report. We often take part in these webinars when reports are launched and we say polite things about the report that is being launched, and then we take the opportunity to talk about other things and to make other points. I'm not going to do that. I'm going to talk exclusively about this report because this report is groundbreaking. It tells us what many of us have long believed to be the case, that the deployment of grid optimization technologies is win, win, win. This is an absolute no regrets option. And it's an option that we can and should be taking already, because at least 2 out of the 3 technologies that Christoph has talked about are already available today on the market. They are already being deployed, namely the dynamic line rating and the modular power flow control. Christoph has highlighted the key points. If you invest in all 3 technologies together, you reduce redispatch costs by 90% and you reduce renewables curtailment volumes by 90% as well. Those are compelling numbers which highlight the compelling case for investing in these technologies. Why hasn't it been happening hitherto? Well, the people who can and should and are going to need to invest in the deployment of these technologies, the TSOs, have, up until now, been somewhat reluctant to invest in them. But I'm not going to beat up on the TSOs because there are 2 very good reasons why they haven't invested as much in these technologies as they could and should have invested in them so far. The first reason is that the regulatory incentives, the investment framework, is not really conducive for the TSOs to invest significantly in them at this point in time. And the second reason is the very natural, one might say conservative, but perfectly natural and understandable view. Well, let's sit back and let others invest in them and see how they work. Are these technologies really yet mature? Let's wait and see. And one can fully understand that mindset. But this report shows us that mindset, we can move on from it now because the benefits are so strong and so evident. It would be very good if the European Commission could widely disseminate this report or even do their own report, which echoes some of these findings and perhaps assesses and then articulates some of the other benefits that Christoph, you have mentioned, which your own report did not highlight. It wasn't the remit of your report. Your remit was to quantify the benefits in terms of reduced redispatch costs and reduced curtailment. But as you said, there are many other benefits. In addition to those that you have listed, Christoph, I would add a few others. The benefits in terms of being able to accelerate the phase out of fossil fuels, because the deployment of grid optimization technologies will enable us to accelerate the deployment of renewables. The benefits in terms of additional flexibility in the grid. It may well be, it probably is the case that the deployment of these technologies will help the balancing of electricity in transmission and distribution networks. They may well, therefore, contribute to enhanced grid stability. I wonder, this is a question, maybe Christoph, you would have a ready answer already, whether the deployment of these technologies would give the TSOs a new capability to offer new forms of system services that would help to stabilize the grid and might enable us to stabilize the grid in perhaps a more economically efficient way, in a more centralized way than the very diverse and disparate, all very good, but very diverse and disparate investment in flexibility services among distributed assets. That's just a stone I wanted to throw into the water. Two final points I wanted to make. Clearly, there are strong benefits from combining the three technologies. I think that calls for some sort of guidance to TSOs on the methodologies that they should apply when considering which of these three technologies they should be investing in and how they can invest in two or more of them at the same time. I hope very much that ENTSO-E will be able to use its excellent Technopedia platform that somebody has mentioned already, to use it proactively to say to your members in ENTSO-E, to say to the TSOs, look, these technologies exist. I know you've got the DLR and the modular power flow control technologies. They're already firmly logged in your excellent Technopedia platform, but ENTSO-E, please use that proactively. Go out there, shout from the rooftops that these technologies are available and they have huge benefits, and help your members, the TSOs, proactively to consider how they could deploy them. But of course, as I said at the beginning, the investment frameworks have to be right. And this is my final point. We all know today that the revenue models by which the TSOs operate, which serve as the incentive for them to make investments in technology and equipment, they are somewhat skewed towards certain types of CapEx investment. Many people, including ACER in a very recent report, also ENTSO-E in a report that you published in April this year, have highlighted the benefits of moving, of the TSOs being allowed to move from CapEx only to a TOTEX, so CapEx and OpEx revenue model, which would help to incentivize these sort of investments. In the United Kingdom, they've actually gone one step further. They're applying something close to the TOTEX model, but Ofgem, the regulator, is also building incentives into the regulatory framework that incentivize National Grid to invest not only in CapEx for the sake of it, but give them a premium for investing in CapEx that will have clear economic and societal benefits, such as reduced redispatch and reduced curtailment, which clearly incentivizes National Grid to invest in DLR and modular power flow control. And what has happened as a result of that? National Grid are investing heavily in modular power flow control. They can't get enough of it. They love it and they are benefiting from it. And it's that sort of incentivizing regulatory framework that we need all over Europe. Thank you very much.
Thank you very much, Giles. And I noted some of your questions, and I think I will hold on to them, and we will come back to them when we get to the Q&A. But I know also what you were saying about having to perhaps change the framework under which TSOs make their investments. And so that is a very pleasing segue to our next speaker, who is Jan Kostev from ACER. And Jan has been working on energy efficiency, well, working on efficient energy infrastructure investments. So Jan, perhaps you could both comment on the report, but also tell us a bit more about this report that both Susanna and Giles mentioned that ACER brought out on efficient investments in infrastructure. Jan, you have the floor. You have 6 minutes.
Thank you. Yes, the report, I think, is best if I just present the slides, and then I will definitely welcome all of the participants to also read the report, which maybe explains all of these issues more in detail. But yes, the issue, which was, I think, many times stated, we have these technologies, the benefits are there, and even if these benefits would be, the 10% of the ones that the Consentec report is showing, I think all the regulated entities should definitely be investing into them. But what we see is that this is not the case. And ACER, together with the regulators, has done quite a lot of effort in investigating the reasons for it. And then what we did was we went to the basics of how a regulated entity works and how the regulated system works. And predominantly what the regulated system uses is a so-called rate of return. Now, what this does is it remunerates regulated entities, so transmission system operators or distribution system operators, based on the costs of the investments that they make, plus, of course, a certain premium on top of it, a certain additional rate. And yes, this worked perfectly fine where you only had one technology. But if you have competing technologies, what this does is favors a high capex investment, meaning that, and I would maybe go even beyond it. It's not just the high capex, it's the high cost. So total cost of the investment, because that is the one that you get paid plus some interest on top of it. So, I mean, a provocative question would be, if you imagine a zero cost solution, what would a TSO get if they implement a zero cost solution, something which is completely free? So they get this magic wand, which they can wave, and then all of a sudden the energy system becomes hugely efficient and it costs zero money. Why would the TSO invest into something like that? Or how would they be remunerated for it? And even all of the incentives are based on the costs of this solution. So right now, whatever you invest is even in a highly, let's say, favorable environment, very incentivized, like Gilles was mentioning in the UK, you still are incentivized based on the cost of the solution. Now, the premium is usually linked to the cost and not to the benefit that the investment brings. So simply the TSO business is not like any other business, unregulated business, where entities would actually strive towards being as efficient as they can be to reduce their costs and to have the highest possible gain. And this, for the transmission system operators, is, and also any other regulated entity, is simply not the case. So if we can move to the next slide. So, of course, when realizing all of this, and it might strike you as a strange thing that we all of a sudden realize this, I think it is a bit strange, but you have to understand that this is in the DNA of the TSOs and DSOs and the regulators for decades, basically, that TSOs are paid back for the costs and so on. So we were saying, okay, but now how to incentivize the TSOs to be more efficient? So how to incentivize green innovation, because we believe innovation is a key facilitator of efficiency. And we were thinking, of course, about motivation. Motivation can be either positive or negative. It can be either a stick or a carrot. But I think we would all agree that creativity cannot be forced. So you cannot use a stick, because then you will have all the regulated entities fighting very much against any idea of, innovative concepts being implemented, and they will do their best to prove that these concepts simply do not work and cannot be implemented in any way. So we need to look at the carrot side. We need to have a positive motivation. We need to have an incentive. But once again, if an incentive does not work on a no-cost solution, it's not a good incentive. So the incentive should not be linked to the cost of the solution if we want to really strive and get the highest possible efficiency out of the system. So our idea is that to bridge the gap between the let's say the business appeal of a classical investment and a smart, efficient investment, we need to look at the benefit side of the investments. So which benefits do these investments bring to the consumers? And let's share these benefits between the consumers and the ones investing, that is the TSOs or the DSOs or any other regulated entity. This can go well beyond the world of electricity transmission. And ultimately, at the end, the network user is the one benefiting. We would have potentially a faster transition to this more efficient grid. We would have, less congestion. We would have less redispatch and all of the benefits that were shown in the Consentec study, and most likely many additional benefits could be achieved. One additional point, maybe to highlight before I stop, is that if you look at the current regulatory framework, what is also a problem is that if the TSOs are not remunerated accordingly, appropriately, I would say, to really stimulate efficiency, what innovation and what efficiency also means for them is higher operational stress. This actually means that you push the bar higher up, so you use more of the existing system, meaning you get closer to its actual physical limits. What it does is, it creates additional stress, it creates additional risk for the system operators. So one additional, let's say, piece of the puzzle that we need to understand in order to really look at the benefit side and share the benefits and really strongly incentivize the system operators to opt for these efficiency solutions if we, at the end, want to have a very efficient system. Thank you.
Thank you very much, Jan. And so interesting now to hear the regulator's point of view, and this to me seems like it's not a new conversation per se. There's always been a conversation between regulators and TSOs about how they should be remunerated. But I guess what we're seeing now is that the context and the needs are changing slightly. So I think we'll be coming back to that in the Q&A. So thank you very much, Jan. We are going to move to our next speaker, who is an academic. He is Gert Brunekreeft. He is from Jacobs University in Bremen, and he is a professor in energy economics. And Kurt, we would like to hear what you think of the report, and also what you think of some of the comments that have been coming up repeatedly so far about how to develop incentives and a regulatory framework that would help bring on the innovative technologies and solve some of the congestion issues. So Gert, if you are ready? Yes, Gert, the floor is yours. You have 6 minutes.
Yes, okay, thank you very much, Jovan. Right, okay, so thank you very much. I'm delighted to be here actually and to say something about the report and these developments with the grid enhancing technologies and the incentives under the regulation. First, about the report, I'm actually very impressed by the numbers, by the sheer magnitude of these technologies. I knew they were more efficient, or at least that's what I picked up, but not that they were that much more efficient. So very important insights, and this should definitely be on the table of the regulators. Now, we also heard that the implementation is low, too low, as you see the numbers. And this raises the question, which was already mentioned, why is implementation so low? And secondly, then what can we do to improve this? And summing up these two questions then actually leads to the world of network regulation, which is my field of expertise. Then the next slide, please. Right, okay, so there is a lot of information here. I'm not going to go through all of this. That would take me hours, which is not, I don't have the time for that. I would only like to point out basically that the points Jan and Giles already mentioned leads to a new development in regulation, which is called output-oriented regulation, which is what I call output-oriented regulation, or also sometimes called output-based regulation. And here the key idea is that with the regulation, we incentivize value creation, benefits which fall upon others, rather than the network operator. So this is a very important new development which is taking place at the moment as we speak. What I would like to say overall about regulation, first, we together with Oxira Consulting in Berlin and London, we did a study for the TSO in the southwest of Germany, Transnet BW in Baden-Württemberg, on precisely such issues. This was about digitalization of the network and the incentives under the regulation and how to improve the regulation to set the incentives. And for Alan, who later will share his thoughts, also 2 years ago, I think, with the same consortium, we did a similar study for TENET TSO, both sides of the border. So overall, I would say that in the regulation, there is actually a lot going on. There is a lot of discussion on these issues, both on the biases as well as on the solutions on how to fix the biases. I would like to point out one thing which I find very important, and that is that in an ideal world, with perfect regulation, you will not actually find many biases. You have to go into the practical side of the regulation, look at the details of the regulation, which is thus also country specific. But if you look into the details of the regulation, then you will find the biases for or against CAPEX and for or against OPEX. Right in the middle, we have a small list with some of these biases. Now, for the rest, I will pick up two solutions, which there are many actually people discuss and debate about, but I picked up two which address actually the issues we discuss here. First, fixed OPEX CAPEX share, which Giles just now mentioned. And secondly, project-specific budget approach. The next slide, please. I clearly actually don't have time to go into the details here and to explain what is going on, but I would be happy to discuss these things with anyone, anytime, just let me know. So the fixed OPEX CAPEX share is a variation of the TOTEX regulation as implemented in the UK by Ofgem, and if I'm not correct, if I'm correct, by Ofwat. Giles just mentioned this. The fixed OPEX CAPEX share is a tool to address the OPEX CAPEX incentive bias. We just heard, this was mentioned, there will be CAPEX biases in favor of CAPEX and away from OPEX. We know this, you have to look into detail to see what the bias precisely is, but there are also ways to address these issues, and FOX or TOTEX regulation is doing exactly that. Without detail, 2 points on this. First, my personal opinion is that the system is very elegant and it looks complicated and strange, but once you have kind of a feel for what is going on, it isn't actually very complicated and it is rather easy to implement. Many issues to be resolved, but at the end of the day, it's amazingly easy to implement, my idea. Secondly, also, the system can be project specific. No need to change the entire regulatory system. No need to implement this for the entire firm. You can pick up a project where we think there may be a bias and implement such a system only for this project. That works perfectly fine. The next slide, please. That would be the last slide as well. An alternative would be, well, you could actually also combine these two systems, but let's say an alternative would be a project-specific budget approach with sharing factors. And a budget approach like this would be an ex ante predetermined project-specific budget, which is specified for the coming years and which can be specified annually and which has to be agreed with the regulator. So the regulator at the end of the day has to approve this. Now, this budget is something the TSO has to work with then for this project. And you can actually differentiate this or improve this for the cost overruns and cost underruns with sharing factors which can be varied for OPEX and CAPEX. This system, a budget approach, addresses base year effects. Why? Because the base year, which is a problem in the standard revenue cap regulation, the base year of a budget approach like this is actually flexible. The base year is the start of the project, and therefore the base year effects, which hinders investment and OPEX expenditures, actually is resolved by this. Good. Last remark. If you start to vary the OPEX and CAPEX specific sharing factors, then you find stereotypes of this budget approach, which balance between the risk for the company on the one hand and efficiency incentives on the other hand. And the balance of this is actually project specific. So summing up, I think the insights of the report presented here are very, very important. It should definitely be on the table of the regulators. And we should definitely look also into the regulation, what stops network operators from investing in these technologies. And we should think about how to address these issues and improve the regulation. Thank you very much.
Thank you. Thank you very much, Gerrit. That was a really useful examples there of some specific regulatory approaches that could be taken, and some of the guidance that Giles was talking about earlier about that people might need. And I think we will come back to that in the Q&A as well. So thank you very much, Gerrit. And now our next speaker is Antonella Battaglini, and she is from the Renewables Grid Initiative. So she works with citizens and TSOs on grid expansion to help meet the needs for climate and more renewables. Antonella, you have 6 minutes. Could you give us an idea of what you think about the report, and also how you see these innovative technologies addressing some concerns that citizens might have about grid expansions and more grid? Antonella, you have the floor.
Thank you very much, and thank you for the invitation to speak in this webinar. So first of all, my opinion is that these type of studies are important, and it is good that it is being done. Of course, from a citizen's point of view, I'm a citizen, so I can express my opinion as a citizen. Probably the immediate reaction is, what else can you get out if a study is financed by the industry that then the study is going to praise? But that said, I think that we have known for a long time that there are technologies already on the market that can improve the utilization of assets. And of course, it is absolutely important that we do explore innovation to increase utilization of all assets, not just electricity grid assets. And if these technologies that have been analyzed in the report can provide a contribution, then they indeed should be utilized. To do this, much has been said from Jan, from Giles, on the reasons why certain technologies are not deployed. I would like to reflect a bit also on this topic, because we can name the reasons, but we need to understand why these conditions are in place. If we really want to change approaches, and we have to change approaches, then what is needed is a completely different mindset. Not towards one technology or one supplier or one solution, because we know well that there are no silver bullets, but there are many, many different options that need to be deployed all at once. And so we need to foster a mentality which incentivize innovation, that somehow create the space for experimenting with new technologies, and also accept that there will be failures. Not all technologies will succeed, but we need to be careful in assessing the ones that are most suited or not. So from a citizen point of view, or even from the environmental discussion that I am often involved in, it is absolutely necessary that the regulatory framework provide incentives for innovation. The regulators need to embrace the future. I welcome this new position of ACER, but this is a minor first step. There is much more that needs to be done by national regulators and ACER as an agency. The professor has mentioned the output regulation or output-oriented regulation. I think this is also an important mechanism that should be further implemented across Europe. We know that it is being deployed in the UK with a lot of success. And finally, I think that every new technology that comes to market has to be fully assessed, not only for the benefit, also for the risk that comport. And in this regard, I would really recommend that the Commission, ACE, and the TSOs carry out independent studies to match the result of the Consentech study. Because one report is good to have, it's fantastic to have, but it's not enough. And therefore, matching studies are urgently needed. Thank you.
Thank you, Antonella. And a good scientific principle then that the results need to be replicated. So a call there for more studies into this. So thank you very much, Antonella. And we go to our last speaker for the panel debate, who obviously we've been hearing a lot about how TSOs should be incentivized, how to motivate TSOs to take decisions. And so I'm delighted that now we have Alan Kroos, and he is working on long-term system planning at ENTSO-E. Alan, you have 6 minutes. If you could give us your views on the report and tell us a bit more about how to optimize the grids. And we've already heard quite a lot from the other speakers today, but it'll be really interesting to have the TSO's views on this. So Alan, you have 6 minutes. Please go ahead.
Thank you very much, and a pleasure to join you, to also be the last in line and represent the TSOs Association and be able to share with you, let's say, ENTSO-E point of view on flexibility for what we try sometimes to say the non-wire solution as presented in the published report. Because indeed the report shows what is possible, what can be done, and takes up. But what I hope, at least with my contribution in this panel, is also to, let's say, show you that TSOs, we don't want to be the conservative guy, which was mentioned earlier on, but rather be also a prudent partner in achieving, let's say, integration of renewables as fast as possible, but still while keeping the lights on 365 days a year and 24/7. and knowing, let's say, the devil is in the details when you're implementing. So excuse us for being prudent, but we would like to make sure that everybody still can use this, let's say, Wi-Fi and join these kind of conferences. The other thing that was also mentioned, and which I also would like to at least give some light on, TSOs are not only, let's say, the money-making machine like any other normal business, but we're also bound by many different codes and legislative requirements in planning and operating the grid. So if we're looking at how to facilitate these things, it's not only about, let's say, the incentives in remuneration, but it's also on the whole spectrum on that part. So we shouldn't forget that one. And last, before I go into how we at N3 do it, let's remember our community is also consisting mainly of engineers, and we're generally very eager and happy with innovation. That makes life interesting. So there is no resentment against innovation. And one of those examples is, for example, we're almost finishing a 4-year study in InnoSys, completely focused on enhancing utilization of existing grids with these kind of technology that has been presented in the report. And we're already trying to plan, let's say, the next step, how to implement some of these ideas in our control centers to also make it work and to show how it can be done as such. So hope to get you a step further. But how do we facilitate this? Because it's quite a big journey. It's not something that happens overnight. And the main process that can facilitate this, according to us, is the legally mandated TYNDP process, which is, let's say, shown here. And there are a couple of steps in that one. The intention is that this process shows transparency what can be delivered. First, by creating scenarios where, let's say, there is a kind of a common opinion, what might happen in the future, different things might happen. We try to take that into account. And then N3, together with all the TSOs, but not only on the electricity side, but also on the gas side, try to define where are the bottlenecks, where do we not meet, let's say, the necessary transport parts. So our identification of system needs. And then it's something that's also quite important. N3 does not deliver the solution. We only show where there are gaps. So projects are then being collected, and yes, mainly from TSOs as one of the biggest project promoters, but also, let's say, third-party project promoters. And then going further into a cost-benefit analysis for each project, which is then handed over to the European Commission process of projects of common interest. How does this materialize? In next slide, I've tried to, let's say, show something, because the focus, as I mentioned, is the identification of system needs. Where are we? The identification of system needs shows us the gap between the necessity from the scenarios and the possibilities within the projected grid. Curtailed energy is also being presented, and it might be a good measure to make use of with a flexible or non-wire solution. In the 2020 report, we already shown that there is 81 terawatt hours that we could capture and we could pick up in a different way. On the 2022 report, we are just starting the calculations, taking into account all the stakeholder feedback from our draft scenario report, but we already enhanced our model to take storage and peaking flexibilities into account as a kind of an investment candidate. So to show that we're not biased towards wired solution, new high voltage line, etc., but proposing different kind of things, which technology is less of important at that part. So looking at all these kind of things, I would like to, let's say, also emphasize indeed, as Suzanne and Giles already promoted, we are, let's say, looking at the Technopedia, the N3 one, to show what we can do, because I think it's a valuable knowledge sharing website. So how to pick up things, how to share things, gives a state of play of different options and examples. So also, let's say, a possibility to contact us. But in the end, we should do it together. So I welcome, let's say, all comments, all, let's say, reservations, and but let's keep in dialogue to try to find the right way forward. And showing with this report what are possibilities is definitely a step that can help us going further. Because as I mentioned, proud of being part of an engineering community mainly, going for new innovation. I mean, nothing against that.
Thank you very much, Alan. And I know there's nothing an engineer loves more than a technical problem to solve.
Yep.
So yeah, I'm sure that there are many more innovations that will come in the future. So Alan was our last speaker, and we want to go to the Q&A. If you have a question, please could you put the question in the Q&A box? We only have a few minutes, and I know that Giles has to leave in a couple of minutes. So if anyone has a question for Giles, they should ask it now. I don't know if anyone actually, just whilst we're here, does anyone on the panel have a particular question for Giles before he has to go? Alan, I mean, I don't know, you were saying about Technopedia. I mean, is that widely, how do you publicize the Technopedia? Giles was very complimentary about it, but Giles, is there something that you could see that ENSO could do more on Technopedia, because it appears to exist, but are you saying that it needs somehow to be more widely disseminated?
Proactive dissemination, and so we should be shouting from the rooftops about it, saying to their members, the TSOs, look guys, these technologies exist, they make sense, they save money, they reduce curtailment and redispatch costs, go out and invest in them. Okay, and I think, Giles, do you have to go now? Is that you finished? Very shortly, yes. Okay, thank you, Giles. Thank you. So we have a question for Professor Brunegrecht for Gert. We had a question about, you were talking in the regulatory examples, you were talking about examples of bias. And the question is whether, do you have any specific examples of where you have seen bias in regulatory incentives? I mean, when I was listening to you, were you talking about, are all these regulatory incentives set in national markets? So you have to dig into the national legislation to find them. So, and in that case, I mean, do you have any specific examples of where you have seen biases so far?
Yeah, absolutely. Thank you very much for the question. So first, indeed, so in many cases, you have to look at the details of the regulation. So these tend to be country specific, right? Okay, so let's say looking from a kind of a perspective of the German regulation, the regulation in Germany, you will find that CAPEX and OPEX are treated differently, right? So CAPEX is now passed through basically on an annual basis, whereas OPEX is still under the 5-year delay period to set the incentives. But this, in fact, might mean, if you do the calculations and the analysis, that it might be more attractive to invest in CAPEX activities than use the substitutes in OPEX activities. And this is due to the asymmetry in the regulation, because CAPEX and OPEX are treated differently. There may be all kinds of good reasons why this is, but an asymmetry typically would create a bias, right? So these kind of examples. Okay, and I mean, you're saying there these biases and the incentives are at national level. Is there a case to have some EU guidance on that? Is it something that can be harmonized, or are the national situations so specific they need specific national incentives? Yes, you could say that. I think what we typically see is that these new technologies we were talking about today tend to be very innovative, and they tend to be OPEX based. And the feeling comes up that the outcome of this is uncertain, that the risk is actually higher for the companies than safety first and put it in CAPEX. It has to do with the regulation and the nature of the investment. So uncertain, innovative, OPEX-based technologies tend to be overall in many countries in the regulation at a disadvantage. Okay. Okay, so we have a question here for Consentec. I know, Christoph, you can see the question. It's asking about the new German government and what their plans are, because we were hearing in all the discussions about how Germany is very important.
Perhaps Suzanne might also comment on that one. Thanks. So the question was what measures the government is likely to take to speed up grid expansion and reinforcement. I think you might well know that what's still on the campaign trail, Olaf Scholz, the new chancellor, announced that he would like to speed up the permit procedure for new transmission lines to 3 years. Which I think is quite ambitious, honestly. Not sure if they'll make that, but definitely a speed up is needed. And what they are aiming at, I think, is, let's say, combining steps which are now kept separately in the planning process, for example. So if new lines are planned first, you look at a wider region, and then you narrow down the corridors for new lines and so on. And that should be, let's say, brought closer together. Also, the process of judicial oversight should somehow be shortened and made more efficient, and additional capacities also in the authorities for permit procedures and so on. Though there are quite some measures which are explicitly mentioned in the coalition agreement. Nevertheless, 3 years seems to be very ambitious to me.
Okay, and Susanna, did you have a view? Do you have a view on that?
No, I think what Christoph said is true. It's also early days. Today, the government comes into being. The agreement is very ambitious. Networks are identified as being crucial. And we will see a network development plan that's called a climate network plan, that they have to start ASAP with the regulator, Bundesnetzagentur. And I'm sure and I hope that all possible measures will be taken into account, and that a report like the one that Constantec has now done will be also considered.
Okay, so I'd like to come back to this. You come back to the regulatory framework, because we heard from Gert there talking about how a lot of it is deep in national legislation. Jan, do you see a need for some EU guidance on regulatory frameworks? Do you think there needs to be, I don't know, a network code or something in EU legislation on this?
I mean, Acer is of course willing to facilitate this discussion. And I agree with what Antonella said, that this position paper we issued is just the first step, and we do plan to have many discussions and open consultations, inviting also other stakeholders to discuss this a bit more in detail, and also to set up this new incentive schemes. Because what I heard from these discussions today, I wanted previously to reply also to Gilles, saying that, you know, this should be shouted from the rooftop. I think the majority of TSOs already know this. It's not that the Technopedia needs to be, you know, thrown at them. They are the authors of it, basically. So they know everything. They know the benefits, but it's simply there is no business case for them to implement them on a wide scale. We also have to acknowledge that the TSOs are in general quite innovative. I mean, they were the ones developing many of these technologies. But when it comes to wide-scale deployment, they simply do not perform. And maybe also a bit of a reply on the incentive part. Of course, the capex bias is a big deal, but it's not the one that is causing, at least in my opinion, the major disruption in that sense. I think, again, if you look at the example of a potential no-cost, so free of charge solution, there is simply no TSO in the world, I would guess, that would implement something like that, because it simply doesn't make sense for them. But okay. Yes, in short, Acer is working on it. Acer will do it. I'm not sure. I mean, if there is any, you know, output in the sense of network code or something like that that could be done. But if we have a good example in Europe, when a country would take this on board and show that it works, then I'm sure the others would also follow. Thanks.
Okay. So it could be led by national measures. Antonella, you have your hand raised. You want to come in on this?
Yes, thank you. I think that what should not be forgotten in this discussion is that we cannot talk in isolation about new technologies and how they increase the efficiency of assets, but we always have to combine it with the need for building additional infrastructure, because around this table, we all know that additional infrastructure is needed. And from a public perception point of view, it would be catastrophic if there is a message going out to say, oh, we have a silver bullet, and this will be abused not to support a build-up of infrastructure. So we need to be careful to have a coherent narrative. And to have a coherent narrative, we also need to release data. So monitoring data on performances have to be collected over a long time and made public. And I think that this is a task that ESA can take at the European level. Thank you.
Okay, well, that's a very good point, because obviously a lot of the issues relating to grid expansion and even the technology issues will rely on public acceptance. So anything that helps the public to accept what's needed will be helpful. We are out of time for our Q&A. It was a really interesting discussion, but we only have a few minutes left. And so I would like to briefly thank everyone on the Q&A. And I would like to introduce Anders Scanlund, who is a board member at Current, and he is going to give us some closing remarks. Anders, you have the floor.
Thank you, Shoban. It has been very interesting to sit here and listen to everybody. Grid capacity is obviously a very key resource in the power system, and the value of this grid capacity is growing fast. It's growing, becoming a limited resource, a scarce resource. We need more of it for the green shifts. The volumes of generation and load are growing, and these new volumes are very different from the old ones. They are variable, located different places, and the grid we have is not built to serve the new generation and load. It's built for the old one. So we need more grids, but building grids takes time. So the lack of grid capacity is now often referred to as the most important barrier for the green shift, possibly also one of the most important barriers for Europe delivering on the Paris Agreement. It is a huge paradox in this situation where grid capacity is becoming so important and scarce that we're lacking very basic knowledge and understanding of the grid capacities. And since we're lacking this information, we're also less equipped to take efficient measures to make better use of it. And we end up being wasteful with this critically important resource. We could have measured the actual true capacity of grids, used technology to help use it more efficiently, but instead we use conservative capacity limits provided by suppliers or grid lines, or we use uncertain estimates. We could have known, transported more power in our lines, included more renewables, decarbonized faster, cut emissions faster, and done it in a knowledge-based and secure manner. But we don't do it yet. To say it a bit bluntly, we are acting a bit wastefully. We could have done a better job, but we lack knowledge, and we neither know how wasteful we are or how much better we could have done. So we need more insight, and this report is a starting point. And as many have said, we need more studies, we need more knowledge. The study presented today, I think it is the first time these technologies are properly included in the European fundamental power market and grid model, so that we can see the effects that these technologies could have. The models used for studying European grids, used to decide on investments in grids, generation, load, and batteries, and so forth, typically assume no use of innovative grid technologies for the decades ahead. This could be a risky assumption for investors and for society. The Consentex study is a start, but it's quite mind-blowing, and it's showing a huge potential. However, it's only scratching the surface. It looks at the effects that these technologies could have on cost of redispatching and on the related curtailment of renewables. The effects found are huge: 90% less money used on redispatching and limiting the curtailment of renewables with 3 terawatt hours. In addition, we know that more grid capacity would improve market integration, reduce congestions, making room for more renewables, more electrification, more competition, which in turn leads to lower power prices, less price volatility, and more emission cuts. None of these additional positive effects of these 3 technologies have been properly studied yet. So going forward, we need to gain more knowledge and be less wasteful. This report is a starting point. Let's hope it's a kickoff, and that this meeting could trigger curiosity and willingness to engage in exploring the potential in technology to make better use of grids, and the grids we have, and also the grids we build. Thank you.
Thank you very much, Anders. And that is the end of the webinar. I understand that it has been recorded and it will be made available on the current website. So it just leaves me to thank all of our speakers, all the organizers, everyone involved in making this possible, and you, the audience, for listening. And I will say thank you and goodbye.
Thank you, Sharon.
Thank you very much. Bye-bye.
Bye. Thanks a lot.
Thank you, everybody.